Describe the two fully singular transformations y equals f of x that have been combined to give the following transformation. So looking at the graph of y equals f of x, we have the point half and half and 1, and we also have the point 2 and 2, and we could see how that has changed to be 6 and 6. And so I could immediately say that, okay, there's some scale factor on the y-axis, because we could see how the graph looks stretched vertically, but we also know that it's been translated. So it's been translated and then it's been stretched, and how much it's been translated is, I think, we could just go and look at the difference. Here this is at 2, this is at 6, so it's moved 4 units, after which the point has been multiplied by 3 to become the way it is. Okay, and that's basically because the ratio here between this point to this point is going to be 3 units in length, but this is only 1 unit in length, and so the scale factor here is going to be 3. So there is a a stretch in the y direction, by a scale factor of 3. And there's also a horizontal, as we mentioned, a translation in the x direction, by translation vector, which is going to be, as we know here, how many units to the left? 4 units to the right and 0. State in terms of y, f and x, the equation of the new graph. So it used to be f of x, but now after a scale factor of 3 in the y direction, it becomes 3 times f of x, and then when you translate on the x direction, so the x changes, and so it becomes f of x minus 4, because it's been moved to the right. This is positive, it becomes negative over here. Let's see question number 4. It says, the diagram shows the part of the graph y equals a tan into x minus b plus c. Given that AB is between 0 and pi, find the values of a, b, and c. Okay, perfect. So firstly, let's just remember how the graph of tangent actually looks like. It's supposed to be that a tangent is supposed to be passing through 0, 0, and at 1 over 4 pi we have 1, at negative 1 over 4 pi it's at negative 1, and it's supposed to look, obviously there's an asymptote here, right? It's supposed to look something like this. Anyway, it changed, however, and this point we could see has been shifted, okay, and I can see how it's been shifted so that it's right over here. So there's a phase shift by there's a horizontal translation where the vector is supposed to be 1 over 4 pi and 0, but there's also a vertical shift, and that vertical shift happens to be or maybe it's not a vertical shift, like this 0, 0. If it needs to go upwards, then we can see here that there is a vertical shift, and that vertical shift is going to be by 1, because you've been lifted up. Like here you can see it was 0, but then it's been lifted up by, yes, exactly, by 1, and so it's not really 1 over 4 pi 0, it's 1 over 4 pi 1. And when it comes to, we already know b is going to be 1 over 4 pi, c is supposed to be 1, however a is supposed to be how much you multiplied. So here you could see, for example, at the point half pi we're having 3, when, as we mentioned, this half pi used to be 1 over 4 pi because of the phase shift, and 1 over 4 pi we had to have 1, and so instead of 3, right now we have the y equals to 3. Let me just erase this stuff so that's it's much clearer. Okay, so let's just look at a point individually. Okay, so we have this point at half pi, and that's going to be 3. Now compared to the initial point, it used to be 1, and that used to be in tangent in general. So this point used to be 1. Now here the difference, we could look at that. You could see here this is 2 units in length, and this is just here from the 0 level, that's just 1 unit in length. And so we can see that there's a scale factor here of 2 in the y direction, and so in this case, a is supposed to be the stretch in the y direction, and that's supposed to be 2. Now we can check, right? We can use, for example, y equals 2 tangent of x minus 1 out of 4 pi plus 1, and then use any point to check. So let's, for example, use 5 over 4 pi. So when you use 5 over 4 pi, 2 tangent of 5 out of 4 shift pi minus 1 at 4 pi plus 1 is equal to 1. And that's right. But what's it called? Let's check another point. How about y equals tangent of 3 over 2 pi minus 1 over 4 pi plus 1. And so here, 3 over 2 pi plus 1, that's equal to 3. And that is right. You can see this is 3. And so this is great for checking. Now let's go ahead and look at question number 2. The graph of what's it called y equals f of x is then transformed into what's it called y equals to 2f of x into minus 1. Describe the two fully single transformations that have been combined to give the resulting transformation. Now you can see here that we have two transformations, one of which is a vertical transformation because the 2 here is multiplied by the whole thing, alright, and then one of which is a horizontal transformation or transformation along the x direction because the x here is the one that has changed. And so since it's like one is in x direction, one is in y direction, the order in which you mention the transformations doesn't really matter and doesn't really affect the final order. And so here you could just simply say that, oh, there is actually a stretch in the y direction. By a scale factor of 2. And then there was a translation in the x direction. And then you could just write down the translation vector. And then he says for part B that the curve y equals sine of 2x minus 5x has been reflected in the y-axis. So if it's reflected in the y-axis, that means it used to be f of x and now it's f of minus x. And then what's it called? Then stretched by a scale factor of 1 over 3 in the x direction, which means that if it was f of x, it becomes f of 3x, because the scale factor and along the x direction has an opposite or inverse effect on the x. Write down the equation of the transformed curve. So now the transformed curve, if we first apply this, it doesn't really matter what order which you apply it, because again they're in different that one is vertical, one is horizontal, so you could just apply either one separately. Sine of negative 2x plus 5x, and then instead of x you could just go with 3x, and so sine of negative 6x plus 5 times 3x, and that's going to be y equals to, negative, you can take the negative outside, 6x plus 15x, and that's the transformed curve. Let's look at question number 6 here. The functions are both defined and are given, and in this case he says, by first expressing f of x and g of x in complete square form, express f of x, what's called g of x, in this form. Let's first express them in complete square form as he asked. So first I'm going to get c by going b over 2 and the whole thing squared, which is minus 2 over 2 squared, which is going to be plus or minus 1. And so I would just say it's x squared minus 2x, add 1, subtract 1, add 5, and then that becomes x minus 1 squared plus 4 equals f of x. And then g of x will equal to, here it's going to be x squared plus 4x plus 4 minus 4 plus 13. And you're going to get g of x to be equal to x plus 2 and the whole thing squared. Minus 4 plus 13 is 9. And so you've got two of them in complete square form. He says to form what's it called, g of x, and express it in that form. So first off, what's f of x plus p or the whole thing plus q? That's supposed to be, just go ahead and substitute that in here. So instead of x, go x plus p. And so and then you add q to the whole thing. And so it's going to be x minus 1 plus p plus 4 plus q. And if you expand the whole thing, and then obviously here you're going to get x squared and then minus 2 into x into 1 plus p, and then plus what's it called, 1 minus 1 plus p, the whole thing squared, plus 4 plus q. What's it called? You also don't need to actually expand if you think about it, so sorry about this. You could just go ahead and directly compare this, to what's it called. This is supposed to be, we got this, and he said that this is supposed to be g of x. And we already know g of x is x plus 2 and the whole thing squared plus 9, which means 2 is equal to 1 minus 1 plus p, and so p equals to 3, and 4 plus q equals to 9, which means that q equals to 5. And so I think that the whole point of this is just to see the transformation that has been applied on f of x to form g of x. And in that case, there will be a horizontal and a vertical one. So describe the Fourier transformation which has changed f of x to g of x. And so we got two transformations, one of which is horizontal, one of which is vertical, so it doesn't really matter the order as we mentioned. And so here you can just directly say that, oh, actually, there has been a translation in the, what's it called, translation in the x direction. You could just directly go with one translation actually. So yeah, translation by a, what's it called, translation vector, which is supposed to be, we're going to go -3 for what's it called p, right? So you're just going to go -3 and then 5 in the y direction. Okay, let's move on to the next one. He says the diagram shows the curve. This is 2021 variant 1. You've got a cosine of bx plus c. Find the values of a, b, and c. Now here you don't necessarily need to do this by using, what's it called, translation and that kind of situation, because like in the case of a, b, and c in cosine, like we're very much used to just saying, okay, a is supposed to be the amplitude, b is supposed to be, helpful in finding the period, and then c or b is supposed to be the number of waves in one rotation, and c is supposed to be the, what's it called, new x-axis. And so in this case over here, what's it called, a is supposed to be the amplitude, but in order to find that, first let's find b, because it's like pretty simple to find. Number of waves in one rotation here, we've got 1, we've got 2, that's 2 waves, and so b equals 2. However, c is supposed to be the new x-axis, and we can see that's clearly around 3, and so c equals to 3. And then the amplitude is supposed to be from a to 3, and from what's it called, 3 to what's it called, -2. And so if we just go from 3 to 8, that's going to be 5. And if we go from 3 to -2, that's also going to be 5. And so we just found the values of a, b, and c. Part B says, for these values of a, b, and c, use the given diagram and to determine the number of solutions. Okay, so to determine the number of solutions in the interval between 0 to 2 pi for each of the following equations. A cosine of bx plus c equals to 6 over pi x. A cosine of bx plus c equals to 6 minus pi 6 over pi x. Now when it comes to having two equations being equal to each other, to use the diagram, we could just go ahead and sketch the line 6 over pi x and see how many points of intersection there are between this and that. So 6 over pi x, firstly let's get some points for 6 over pi x. Now here we can, for example, at the point pi, right, so x equals pi, y is going to equal to 6. And so we've got 1 point figured out, okay? We also know that at the point 0, y is also going to be 0. And so this is the line that we're talking about, okay? And here, how many points of intersection? You have 1, 2, and 3. So you could just directly write 3. And then what's it called? Next, we can also find 6 minus 6 over pi x. So now, what's it called? 6 minus 6 over pi. You can, for example, use the point also pi, and that's going to be at 0. So at pi, we're going to have 0. But then let's try, for example, 0, you're going to be at 6. So that's the y-intercept. And so here you could just draw this, and you're gonna get 1 and 2 points of intersection only, and that's it. And then let's move on to question number 2 here for variant 2 of October, November 2021. Does the graph of y equals f of x is transformed to the graph of y equals to f of 2x minus 3? Describe the 42 single transformations that have been combined to give the resulting transformation. Okay, so you could see again these are in different directions, so it's like, again, it's pretty easy to just mention any one of them, no matter the order. So here you're just going to get, okay, for the first one, it's going to be a translation with a translation vector, so along y direction. And translation vector is 0 minus 3, but then there's also a stretch in the x direction. But the stretch in the x direction is going to be with a scale factor equals to 1/2, because again in the x it's going to be the reverse order. Anyway, there's this point 5, 6 that lies on a transformed curve, and this is a transformed curve. So you could see there was like a theoretical, you multiplied by half for the x and then subtracted for y by 3. So it's x times half and y minus 3. Anyway, this point is supposed to be on a transformed curve. He says, state the coordinates of the corresponding point okay, so the original point corresponding to the curve y equals f of x. So we know that 1/2 x equals to 5, and that y minus 3 equals to 6, which means that now the point is going to be y equals to 9, x equals to 10. Okay. Question number 1 says, the graph shows y equals f of x is transformed to the curve here. It says, describe in fully correct order two transformations which have been combined. So because there's a negative sign Now, because here, in this case, there's like two transformations that are on the vertical direction, you're going to have to move in the order of, what's called operations. And so you can just go ahead and say that actually there was a reflection of what's it called on the not on the y-axis, the x-axis, right? On the x-axis. And then there was also a translation, and the translation vector was what's it called 0 and 3. Okay, now that was it. Thank you guys for watching. Have a nice day.